Mental health is metabolic health, and metabolic health is mental health. In today's compilation video, we're going to prove that. We're going to walk through studies on chronic stress, autophagy, and depression, the link between whole body inflammation and anxiety, how social stress can harm your DNA and what to do about it, how diet soda, maybe the diet soda you love, can harm not just you, but also your loved ones, and so much more. You're going to want to lock in for this one. We're going to go deep. And while you're watching or listening, if you have a strong reaction to something I share, let me know in the comments, positive or negative. Your comments let the algo know we care. Now, let's learn. What causes anxiety?
Hello! I'm anxiety.
Obviously, the answer is many things. But an underappreciated truth is that behavior states and emotions, including anxiety, can be the consequence of a metabolic state. Brand new data show how inflammation, activation of the immune system, and certain signaling molecules can act directly in the brain to promote or soothe anxiety. Now, this one is somewhat personal for me. I spent years suffering from inflammatory bowel disease, ulcerative colitis, and it was catastrophic for my mental health. It certainly caused anxiety. But broadening beyond my own experience, doctors have long observed a curious phenomenon. After certain inflammatory infections or flare-ups of autoimmune diseases, like ulcerative colitis, some people experience mood swings and anxiety even after the infection or the flare resolves. There's a prolonged effect on mood and anxiety. And these new data shine a light on both my personal experience and that phenomenon. They argue that inflammation doesn't just make you feel physically sick. It can have direct actions on the brain to cause anxiety. Now, let me show you with data. The story of the study begins with its antagonist, its villain, the inflammatory molecule called interleukin-17, or IL-17 for short. Now, to be clear, inflammatory molecules like IL-17 aren't just bad exactly. I'm simplifying here. Inflammation is part of the immune response and has its functions. But in this story, and in the modern world in general, IL-17 is the culprit. IL-17 levels are increased in inflammatory disorders like psoriasis, inflammatory bowel diseases, ulcerative colitis and Crohn's disease, rheumatoid arthritis, and ankylosing spondylitis, among others. IL-17 levels and elevated IL-17 levels in inflammatory diseases are certainly relevant to humans, maybe you or a loved one you know. But to prove a causal connection between IL-17 and anxieties, researchers turned to animal models in which they can do experiments. Researchers treated mice with a chemical that increases IL-17 levels. And this made the mice more anxious on 3 different validated behavioral tests as compared to control animals. And next, to connect the dots, the researchers looked for IL-17 receptors in the brain. Indeed, they found that IL-17 receptors were concentrated in the anxiety center of the brain, the basolateral amygdala. And they found that directly administering IL-17 into the brain induced anxiety. Furthermore, chemically turning on or off these neurons, like a light switch, in the basolateral amygdala, the neurons that harbored these IL-17 receptors, this turned on or off anxiety in the animals, respectively. Pretty cool. And this strongly suggests that neurons in the basolateral amygdala of the brain can cause anxiety, and that increasing levels of the inflammatory signaling molecule IL-17 activates these basolateral amygdala neurons to promote anxiety. Now, to delve one level deeper on how this works, in a subsequent experiment, the researchers showed that IL-17 makes these neurons in the basolateral amygdala more excitable. Basically, IL-17 makes these neurons more prone to fire. Neurons communicate with each other by firing off things called action potentials. And IL-17 made the neurons fire and fire more rapidly. You can see that here in figure 5b from the paper. The spikes you see represent voltage traces from neurons given different levels of current. And there's clearly more activity, more neuron firing in the IL-17 treated neurons as compared to controls. In a way, it's analogous to the human behavioral state of anxiety. Because if you're feeling more anxious and someone taps you on the shoulder, you're more excitable, more likely to jump. It's similar with your neurons, and IL-17 is one chemical making that happen. But there's also a counterbalance, an anti-inflammatory molecule called interleukin-10, or IL-10. Whereas IL-17 increases inflammation, IL-10 reduces inflammation. It reduces excitability of neurons in the basolateral amygdala, and it appears to reduce anxiety as well. So, in summary, stepping back, looking at the big picture, inflammatory molecules, IL-17, and anti-inflammatory molecules, IL-10, signal as neurotransmitters in the brain. They bind to receptors in the anxiety center, tuning anxiety up, inflammation, or down, anti-inflammation. This has real-life practical consequences. It implies that altering levels of these inflammatory and anti-inflammatory molecules through lifestyle or through innovative future medications, we could directly influence brain activity and mood states. Let me give you some examples from the literature. Data suggests that westernized diets rich in sugar and processed foods associate with increased IL-17 levels. Now, obviously, a westernized diet is complex. There's a lot that goes along with it. But the point is that living this way, this westernized lifestyle, can have a direct and material impact on anxiety and mental health. So that so-called happy meal might actually be an anxiety meal in disguise. Ba-da-ba-ba-ba, I'm having an anxiety attack. And even electrolytes may impact IL-17 levels. In one study, potassium supplementation against the backdrop of a high sodium diet was linked to reduced IL-17 levels. So electrolyte balance could influence IL-17 and therefore influence anxiety. And in another study, pigs supplemented with beta-glucans from certain seaweeds were also found to have reduced IL-17 levels. Kind of interesting, right? It may be an excuse to go get sushi tomorrow. Anyway, what does all this mean? It means anxiety is not just in your head. It's in your body too. Your immune system and your brain are in constant conversation. Inflammatory molecules like IL-17 can dial your brain into a hyper-anxious state, whereas anti-inflammatory molecules like IL-10 can calm it back down. And the choices we make every day, what we eat, how we move, how we sleep, my sleep's kind of crappy, maybe that's why I have anxiety, how we manage stress, I don't meditate that much, but I probably should, they all feed in to the inflammatory balance. And you've now seen what I've identified for my areas of improvement. Anyway, this doesn't just mean inflammation is the only cause of anxiety, but it is a powerful, underappreciated lever that we can pull to influence our mental health. For me, this new paper, this learning, was empowering. It gave me a new lens through which to view my own struggles, not as a personal failure, but as a physiologic response to inflammation. And for all of us, it opens doors to new strategies for healing. Yes, there is a role for therapy and medication. I'm not saying there's not, but there's also a role, a big role, for food, for sleep, for gut health, for lifestyle, for treating the body to treat the mind. Because at the end of the day, mental health is metabolic health, and metabolic health is mental health. And by tending to both, we can begin to turn the tide on anxiety, not just with willpower, but with metabolic wisdom. This new paper about the neuroscience of depression is one of the coolest mental health papers I've ever read. It reveals a possible central biological mechanism by which chronic stress can contribute to depression, and it opens up doors to innovative solutions for improving depression and mental health. I'm going to walk you through the data, and for this one, I really want to show you the details, so I'm going to ask you to brace yourself. There will be graphs and there will be scientific jargon, but I'm going to do my best to bring you along in a digestible way so you can get the big picture while also appreciating the really important nuances. So, Let's get into it. I'm going to start by describing a key brain region called the habenula and a key process called autophagy that are important to understanding the neuroscience of depression and our story in this video. The habenula is a region in the middle of the brain important in processing aversive and unpleasant stimuli and in the stress response. And because I love memory tricks, hopefully you do too, the way I remember this is habenula sounds kind of like habanero, the spicy pepper that can be about 100 times hotter than a jalapeno pepper, and therefore constitutes an aversive and unpleasant stimuli, at least for most people. So now you won't forget. Habanero, habenula. Specifically, the lateral habenula, is important in processing responses to unpleasant stimuli and stress. So lateral habenula is kind of synonymous with the stress and depression center of the brain, at least for the purposes of this paper and this video. Now, autophagy. Maybe you've heard of autophagy. You can think of it as the brain's janitor crew. It's a built-in cleanup and recycling system within cells. When proteins get old or broken, a membrane wraps around them like a trash bag. It's called an autophagosome, isolating the waste from the rest of the cell. And that trash bag, that autophagosome, then fuses with the cell's digestive center, called the lysosome. And this breaks down the waste for reusable parts and recycling. But here's the catch. Under chronic stress, it's like the janitors go on strike. The trash piles up, the system clogs, and neurons start to malfunction. That's where things start to go wrong and potentially spiral towards depression. And that's at a very high level what they show in this paper. They show that autophagy within the lateral habenula, the depression center of the brain, is impaired with chronic stress, contributing to depression. But now, let's walk through the data with more detail. Talk about what they mean, and talk about their implications and possible solutions, and why I'm so excited about this paper. Okay, first it's important to note there are already data suggesting that autophagy is impaired in people with mental health disorders, including depression. So some autophagy markers are decreased in the blood and brains of people with depression. But you can't do experiments on living human brains to prove a causal relationship. That wouldn't be ethical. So to show impaired autophagy causes depression, you need to use animal models. And in this study, they used mice. So what the researchers did is subjected mice to various chronic stress protocols. Each of these chronic stress protocols caused depression and decreased autophagy in the lateral habenula. You can see that here. What I'm showing, this is figure 1G from the paper, is the result of an experiment where they exposed mice to acute short-term or chronic long-term stress and measured levels of a protein called P62, which is normally broken down by autophagy. Therefore, taller bars mean less P62 breakdown, mean less autophagy. And you can see taller bars in the chronic stress conditions, meaning autophagy is inhibited by chronic stress. You can also see a clear difference between chronic stress and acute stress, where acute short-term stress is like a zebra running from a lion. It activates autophagy. P62 levels go down. Chronic long-term stress is the opposite. This is like a stressful job, an abusive relationship, or poverty. These chronic stressors inhibit autophagy, which you can see with the increasing P62 levels. And this is an important point because it makes the point stress isn't bad per se. The stress response helps us deal with challenges. But when a stressor is persistent and ongoing, it can create an unbearable burden that results in negative consequences, including depression. And this is reflected at the cellular level, where chronic stress inhibits autophagy, whereas acute stress activates it. You see that oppositeness? It's really interesting. And you can also see that here. This is figure 1H from the paper. The green dots represent autophagosomes. Remember the trash bags? The structures involved in autophagy? In acute stress, you can see autophagy increasing, lots of little green dots, lots of autophagosomes. But in chronic stress, there is no visible autophagy. Autophagy is inhibited by chronic stress. The mechanisms behind this were that chronic stress activated a protein complex called mTOR. mTOR inhibits autophagy, and we'll come back to mTOR a little bit later, so you can put a sticky note on that in your brain. So, if this is relevant to humans, one might hypothesize, this is the next step in the research, that antidepressant medications would work by restoring autophagy in the lateral habenula. So to test this, the researchers gave mice paroxetine, which is a serotonin reuptake inhibitor, class of antidepressants, and ketamine. And both paroxetine and ketamine, despite being very different medications, they both increased autophagy in the lateral habenula. And when autophagy was blocked, both of these antidepressants no longer worked. This strongly suggests that these very different medications both act as antidepressants through a shared mechanism by increasing autophagy in this depression center of the brain, the lateral habenula. But the researchers didn't stop there. I told you, remember mTOR? mTOR inhibits autophagy, and a drug called rapamycin, it's kind of known as a longevity drug, you may have heard of it, it inhibits mTOR. So if you inhibit the inhibitor of autophagy, what you'll do is you'll activate autophagy. This predicts rapamycin could improve depression. So does it? In mice, it does. It does exactly that. And fascinatingly, I didn't know this, but rapamycin also has noted antidepressant effects in human beings, particularly when combined with ketamine. They honestly don't teach you that in medical school. At least I can tell you they didn't teach me that at Harvard Medical School. But this mechanism explains why. It explains why paroxetine and ketamine and rapamycin, despite being very different drugs, all can improve depression. But we're not quite done with the nitty-gritty. There's one more piece to the puzzle. How do we connect autophagy and neuron activity in the lateral habenula? How does autophagy modulate neuron activity? Well, neurons communicate with each other via electrical signals. And what determines how often neurons fire signals at each other is chemical input in the form of neurotransmitters. And some neurotransmitters excite neurons, others inhibit neurons. And the balance of the excitatory and the inhibitory signals determines how active neurons are, how often they fire. Now, the main excitatory neurotransmitter is called glutamate. And what the researchers found is that chronic stress decreased autophagy, remember? Which led to a selective decrease in the breakdown of glutamine receptors. Okay, I know I might be losing you. I hope I'm not losing you. What this means is that chronic stress leads to a buildup of receptors for glutamate, the brain's go signal, this excitatory neurotransmitter. And with more glutamate receptors, neurons in the lateral habenula, they become hyperexcitable. Imagine your brain's volume knob, at least in the lateral habenula, getting jammed at max. Everything feels too loud, too much. This is what happens when neurons in this brain region, the lateral habenula, overfire. It amplifies feelings of distress and despair. So summarizing, putting it simply, chronic stress decreases autophagy in the lateral habenula. This increases the number of glutamate receptors, leading to neurons firing in the lateral habenula a lot more and more depressive symptoms. I realize this is rather technical, but I hope it made some sense. You can tell me in the comments if it did. So, now that we've learned together how chronic stress rewires the brain, the next logical question is, well, what can we do about it? So here are 5 quick, practical, and science-backed ways to reduce chronic stress and potentially support brain health and emotional resilience. Okay, number 1, embrace predictable routines. Creating structure in your day, a predictable daily routine, helps send a safety signal to your nervous system and reduces mental load. So try to go to bed at the same time, eat at the same time, move your body at consistent times. Don't be overly rigid with this. That'll just create more stress. But do try to have some degree of consistency and routine. 2, prioritize sleep. I know that's an obvious one, but it's a really important one too. Sleep restores both psychological and cellular balance. It literally cleans your brain. When you're sleeping, this system called the glymphatic system rinses away toxic waste out of your brain, and it's most active during sleep. If you want more details on that and how it works, see this video. It's fascinating science that we're just beginning to unravel. Okay, tip 3 is to engage in short-term, not long-term, short-term controlled stressors. These brief hormetic stressors, like cold exposure, strength training, or high-intensity exercise, they can build up cellular resilience to stress. Stress isn't the enemy. Chronic stress is. And in general, forcing yourself willfully into stressful situations for short periods of time can enhance your ability to deal with stress, including chronic stress. So get that high-intensity workout in, do that cold plunge even though it's hard, and you'll deal with stress better. 4. Practice daily mindfulness and breath work. Just 5 to 10 minutes a day of slow breathing or meditation can activate your parasympathetic nervous system, your rest and digest system, and help calm an overactive stress response. The best protocol, in my opinion, is probably the physiologic sigh, where you have 2 stacked inhales followed by a long exhale, like this. And you can read this paper for more on the benefits of that routine. Finally, 5, and I think this is the most underrated biohack maybe in the world. Connect with others. Social connection isn't just a luxury, it's biology. Meaningful relationships buffer stress and reduce cortisol. For example, in one study examining cortisol level in hair, which can be used to measure cumulative cortisol production, emotional closeness, quality relationships, was associated with lower cortisol levels. So the conclusion of that particular paper is social intimacy can affect health by influencing the stress response, the HPA axis, lower cortisol levels. So yes, a long walk with a friend, sex with a loved one, or a good board game with family can all be brain biohacks. Kind of cool, right? So summing up, why does any of this matter? Because depression is real. Chronic stress is real. They aren't just emotional states. They're physiologic processes, or the consequences of physiologic processes that change how our brains function at the cellular level. This paper gives us powerful insights that chronic stress damages the brain's ability to clean itself and regulate itself. And this may be central to depression. But here's the hopeful part. Autophagy is modifiable. It's not static. It's influenced by how you eat, move, sleep, breathe, connect, and yes, by medications when needed. I will emphasize that depression isn't caused by one single mechanism. It's a multifactorial, complex condition. So while this study offers a really valuable piece of the puzzle, I hope you found it fascinating, it's not the whole puzzle. What if I told you that a common kitchen spice could work as well as prescription antidepressants? It sounds too good to be true, right? Well, the science on saffron is shockingly strong. And in this video, I'm going to walk you through some of that mind-blowing science, including controlled clinical human studies, meta-analyses. I'll explain the neuroscience, and I'm going to show you how this golden spice might really be the next big thing in mental health. Plus, I'll even give you some free, delicious, therapeutically dosed recipes to try at home. But first, let me arm you with some background on saffron, this amazing spice. Saffron is derived from the Persian saffron, meaning gold strung, which refers to the golden stamens of the saffron flower, which is basically the flower's, let's say, male reproductive organs. So, handle with care. Now, as some of you may know, saffron is known for being the world's most expensive spice at about $5,000 per pound. But before you go selling your belongings to afford it, let me reassure you, it actually costs less than a cup of coffee per day at therapeutic doses. But more on dosing math later, I promise. Anyway, saffron has historically been used in traditional Persian medicine for depression. But rigorous human studies on its mental health benefits started in the early 2000s, which brings us to our first study, a 2005 double-blinded randomized controlled trial comparing 6 weeks of saffron supplementation to fluoxetine, a commonly prescribed SSRI sold under the brand name Prozac for depression. It was conducted in 38 patients, again, over 6 weeks. And impressively, the saffron capsule, dosed at just 30 milligrams per day, performed equal to the fluoxetine, equal to the Prozac. You can see the results here with the Hamilton Rating Scale for Depression dropping in lockstep between the treatments. Now, the absolute decrease in both treatments, the saffron and the fluoxetine, the SSRI, was greater than 12 points. But what does that number actually mean on this scale? Well, in clinical trials, I want to point out there's a distinction between statistically significant and clinically significant differences. A statistically significant difference means there was a detectable numeric difference, as in over time or between groups. Conversely, and actually more importantly, a clinically significant difference means the size of the change was detectable and meaningful for the patient and their quality of life. Now, while it's somewhat arbitrary, a clinically significant change in this particular depression scale is around 5 points, which means a 12-point drop with saffron is impressive and actually clinically substantial. So these findings are incredibly uplifting. And quickly, before I move on to the next study, I'll point out that one presumed advantage of saffron over prescription medications is that it could have fewer side effects. And in this first small pilot trial, while there was no statistically significant difference in side effects between groups, that may be because the trial was too small and underpowered to detect differences. But if you look at the actual numbers shown here, I think you can see a clear trend towards lower side effects in the saffron group as compared to the prescription medications. Do you see what I'm talking about? Now, moving on to our second double-blinded randomized controlled human trial, because in science, we like to reproduce our results. But in this trial, they compared 50 milligrams twice per day of saffron to a placebo control for 12 weeks, so higher dose for longer time, and with a placebo control, not an SSRI. So whereas in the last trial, it was good to see saffron perform equal to the control, an SSRI, drug for depression, here we want saffron to perform better than the control, which is a placebo. And indeed, in this trial, including 54 completing participants, the saffron improved scores on the Beck Depression Inventory and Beck Anxiety Inventory significantly more than the placebo control. Pretty cool, right? Now, rather than working through another 20 plus randomized controlled trials, I want to read you some excerpts from a meta-analysis of 23 randomized controlled trials conducted on saffron for mental health, including depression and anxiety. So here we go. It reads, meta-analysis found significant and large positive effects for saffron, reducing symptoms of depression in comparison with a placebo. It also reads, when compared to antidepressant medications, like SSRIs, there was no significant difference between saffron and these medications. And finally, the meta-analysis of studies investigated the effects of saffron as an adjunct to pharmacotherapy and reported large, significant benefits from saffron supplementation. So I know that was a little bit jargony. So let me translate those 3 bullets into simpler terms. Saffron's effects alone were large and positive for mental health. It also performed as well as commonly prescribed medications in human randomized controlled trials. And it provided additional benefits when stacked on top of these prescription medications. Basically, everything you could hope for. And the effects on anxiety were similar to those in depression. And if you do end up reading this meta-analysis, you may note they report something called publication bias. But correcting for publication bias only strengthened the results, increasing the effect of saffron on mental health. And if that last little bit went over your head, just focus on the big picture. In these controlled human trials, saffron, the spice saffron, showed significant positive effects on depression and anxiety. Pretty amazing. Now, I'm sure you're wondering, how how does saffron work? It's freaking spice, right? Well, while the exact mechanism isn't worked out, it is known that components of saffron, including crocin, which is responsible for saffron's color, and saffronel, which imparts saffron's aroma, inhibit the reuptake of dopamine and serotonin to boost levels of these critical mood-regulating neurotransmitters in the brain. This is similar to the mechanisms of action of commonly prescribed medications in psychiatry. And saffron also has powerful anti-inflammatory and antioxidant properties, which you can think of as helping to soothe and calm the brain from a metabolic perspective. Saffron can also lower the stress hormone, cortisol, and increase levels of the brain healing factor, brain-derived neurotrophic factor, or BDNF. And of note, at a population level, depression and other mental health disorders are associated with inflammation, oxidative stress, higher levels of stress hormones, and lower BDNF. Thus, these mechanisms by which saffron impacts metabolism provide a clear biological rationale to support the clinical effects in the randomized controlled trials we just reviewed. The pieces of the puzzle fit together perfectly. Now, on dosing. The most common dose used in the randomized controlled trials in the meta-analysis was 30 milligrams per day, with the second trial we mentioned using a higher dose of 50 milligrams twice per day, which amounts to 100 milligrams. Now, even if we use that upper bound of 100 milligrams per day for a conservative price estimate and price saffron at $5,000 per pound or $11,000 per kilogram, a one-day dose of saffron would only be $1.10 per day. And if you dosed at 30 milligrams per day, that's only 33 cents per day. Kind of cool, right? Now, I'm sure you want to know whether you can get this dose in a yummy recipe. And the answer is yes. And if you're thinking, finally, a reason to eat mayo by the spoonful, you're in luck. Or that might just be me. Anyway, 1 teaspoon of saffron is about 700 milligrams. So in the video notes, I'm going to share with you free recipes that will give you presumably therapeutic doses of saffron in each serving. For example, this keto saffron panna cotta uses a 1/4 teaspoon per 6 servings, which yields about 30 milligrams per serving if you do out the math. It's really ironic that this recipe doses saffron like most randomized controlled trials. To be honest, this is a friend's recipe, and that's totally coincidence, but a positive one. And this homemade saffron mayonnaise uses 1 teaspoon of saffron and yields 19 tablespoons of delicious creamy mayo. That's about 37 milligrams per tablespoon of mayo. That's therapeutic mayo for depression. I know, kind of crazy. And this low-carb paella doses saffron at a pinch per 6 servings. So you can tailor it. If you want a 30 milligram serving per dose, then use a 1/4 teaspoon. And you can double or quadruple that to a half or a full teaspoon in order to get higher doses of saffron in this delicious paella. Men, this drink could be screwing with your swimmers. You know what I mean, your sperm. It's a hard truth. Do you have the balls to hear it? All right, in this video, I'm gonna quickly drill you with some data before we cuddle up with a broader point about interpreting animal model literature in science in an intellectually honest way. Get ready, these data go deep. Now, the paper I want to spend a few minutes exposing you to was published in PNAS. No, get your head out of the gutter. I said PNAS, which stands for the Proceedings of the National Academy of Sciences, which is a rather prestigious journal with an unfortunate abbreviation in this case. Basically, the researchers in the study exposed mice to low-dose aspartame, the artificial sweetener found in diet sodas. The mouse-to-human equivalent, the dose used in the study, was the equivalent of 2 to 4 small 8-ounce cans of aspartame-sweetened diet soda per day, as it says explicitly in the paper. Now, exposure to this low-dose aspartame caused anxiety in both male and female mice over 12 weeks, as measured by validated behavioral tests, like this open field test, where lower levels on the chart indicate more anxiety-like behavior. Now, the mechanism at play had to do with changes in levels of receptors for key neurotransmitters in the brain: glutamate, an excitatory neurotransmitter, and GABA, an inhibitory neurotransmitter. Changes in the emotional center of the brain, including the amygdala. Now, I know what you're thinking. Wow, this research goes deeper than a prostate exam from an over-enthusiastic urologist. But we're not even at the interesting part. Yes, there was a clear behavioral effect of a low-dose aspartame and a reasonable biological explanation: the messing with the balance of the excitatory and inhibitory neurotransmitters in the brain. But the really terrifying thing, at least to me, was that this effect was transgenerationally inheritable. In other words, the offspring of these mice, and even the grand offspring, had signs of anxiety on validated behavioral testing despite never having been exposed to aspartame themselves. You can see that here. Again, in these graphs, where lower indicates more anxiety-like behavior in the offspring, the children, and the grand offspring, the grandchildren of these mice, despite no aspartame exposure themselves. Take a minute to think about how profound that is. The aspartame equivalent of even just 2 to 4 diet sodas per day, and the small ones at that, the 8-ounce little cans, can lead to increased anxiety in the offspring, the children. But, of course, the immediate retort is always, but these are just animal data, with the implication being that I, or others who talk about the potential dangers of chemicals like aspartame in our food supply, are overreaching on the data and creating unnecessary fear-mongering, if you will. At least, that's usually, or seems to me, usually to be the accusation rendered by the diet soda defenders on the internet. But now I want to ask you a question. What human data will be required to demonstrate without a shadow of a doubt that diet soda or other aspartame-containing foodstuffs cause transgenerational anxiety in human children and human grandchildren of human aspartame users? Well, you'd probably need a multi-generational randomized controlled trial where you take a large group of humans, it needs to be large because you need it to be a pretty high-powered study, and randomize a subset to consuming a specific aspartame-containing food dose, and others to consume no aspartame. Then you need to follow them and their children, and potentially their grandchildren, for the next 50 to 60 odd years. Guess what? This study will never be done. So, in disregarding animal data with the statement, but prove this works in humans, one often overlooks practical limitations of the scientific method and creates an impossible burden of proof. To hammer home this point with a provocative analogy, imagine if we applied similar logic to smoking. If we dismissed all but the perceived top-tier human randomized controlled trial evidence for smoking and health risks, and waited for a 50-year randomized controlled trial to be conducted, say, for cancer outcomes and mortality, millions of people would die because no action would be taken, waiting for data that will probably never exist. Sometimes, waiting for the perfect proof isn't wisdom, it's willful ignorance. Now, to be clear, I'm not saying drinking diet soda is as bad as smoking. I don't believe that. I'm just clarifying that because I know someone somewhere is going to go on some angry rant about this problematic equivalency. It's an analogy. But I actually think it's a fair one. It's simply emphasizing that data are often imperfect, incomplete, and we need to make do with the data we can collect and have collected, which almost always has major caveats. Then, given imperfect and incomplete data, we must make calculated health decisions. In this case, I'll walk you through my own mental calculus as an exercise. Okay, diet soda may mess with my sperm and put my children at higher risk for anxiety or other mental health disorders. Do I know this will happen for sure? No. But is there a chance? Yes, there is. So I've identified the risk as an uncertain but potentially high impact negative outcome. How about the reward? Well, for me, 0. The cost to me of giving up diet soda is nothing. I think water is fine, sparkling if I'm in the mood for it, and even if I were to want a diet soda, I know I could opt for one with an alternative sweetener that I deem safer, like stevia or monk fruit or allulose. That would be my preference. I definitely think it's safer than aspartame-sweetened diet sodas. So the risk-benefit analysis, to me, makes it clear that I'll probably never have another aspartame-sweetened diet soda as long as I live. Otherwise put, if a drink might sabotage my sperm, I'm pulling out faster than, well, you get the idea. Oh, and if you perchance wanted to hear the author's own conclusions from the paper, here's an excerpt straight from the paper. I'll read it for you. Extrapolation of these findings to humans suggests that aspartame consumption at doses below the FDA-recommended maximum daily intake may produce neurobehavioral changes in aspartame-consuming individuals and their descendants. Thus, human populations at risk of aspartame's potential mental health effects may be larger than current expectations, which only includes aspartame-consuming individuals. At the end of the day, this isn't about fear-mongering. This video isn't about fear-mongering. You're an adult, you can make your own decisions. It's about understanding the risks and making an informed choice given the data at hand. We may never get a perfect long-term multi-generational human study proving with absolute certainty and without a shadow of a doubt that aspartame messes with our brains, sperm, and our children's mental health. But dismissing compelling animal data just because it's not human data, that's not science. That's denial. So here's the question you need to ask yourself. What is diet soda, specifically aspartame-sweetened diet soda, really worth to you? You don't have to agree with me. You don't have to have the same mental calculus, but at least be honest about the trade-offs. Because when it comes to something as important as your health and possibly your future kids' health, waiting for perfect proof might just be the worst mistake you could make. What if I told you that social stress doesn't just mess with your head, it damages your DNA and biologically ages you? That's not hyperbole, it's not exaggeration. It's based on science from new data published in the journal Nature Aging. And if you're like me, juggling a life full of psychological stress, you might be wondering, how can we fight back against the age-accelerant effects of stress? Stick with me, because by the end of this video, I'll share 3 tips to help you turn these lemon of data into practical mind hacking and biology hacking lemonade, including a powerful randomized control trial-backed breathing technique that could take just 5 minutes per day and could help you combat the harmful effects of stress on your biology. And make sure to stick around to the end to hear directly from the first author, Dr. Carrie Lyons herself. But moving on, I want to give you background on aging. Aging is complex, and there's no one easy way to measure biological age. It's a little bit of a fluffy term. However, certain hallmarks of aging, like DNA damage, telomere shortening, and cellular senescence are widely recognized. Senescence is the focus of this paper, and it's a process by which cells age and permanently stop dividing. Senescent cells accumulate as we age and play roles in chronic diseases like heart disease and Alzheimer's disease, dementia. Now, while senescence does have some adaptive functions, I want to put that out there, for our purposes, it's fair to call senescence a hallmark of aging. Now, senescence can be triggered by various pathological processes, including inflammation and DNA damage, which we'll also tap on later. And senescence can be measured using markers like P16, which is the focus of this paper. And if you want to remember this, just imagine the stress of having a pissed off 16-year-old kid. I don't know, I don't have a teenager of my own, but I can imagine it's stressful. Anyway, in this study, the researchers subjected mice to chronic social stress, or more specifically, chronic subordination stress. The experimental mouse is exposed to an aggressive dominant mouse every single day. The human equivalent of chronic subordination stress, chronic social stress, will be like a bully at school, or an abusive parent, or a hyper-aggressive boss. And in just 4 weeks, the experimental mouse, the one that got bullied, exhibited increases in markers of senescence, predominantly P16, this marker I mentioned earlier. And this marker of senescence and biological aging accumulated over time, with levels getting to as high as 12 times that of control mice by 26 months of age in circulating blood cells, as you can see here. But if only it were just circulating blood cells. The researchers then found something really scary. The cell type most sensitive to stress-induced senescence were neurons in the brain. You can see that here. Red marks senescent cells, the P16 labeled cells, and you can see they're massively increased in mice subjected to chronic subordination, chronic social stress. That's the red bar. And they found evidence consistent with the hypothesis that the senescence and presumed biological aging were triggered by DNA damage, which can be measured by a marker called gamma H2AX. It's not very important, but that's what you see here. A massive increase in DNA damage in chronic subordination, chronic social stress, and an increase in inflammation. So to summarize quickly, chronic social stress causes DNA damage and inflammation in association with increases in a marker of senescence and biological age, that P16 we talked about. And this occurred especially in the brain's neurons. Pretty scary, right? And it's also worth noting chronic social stress is also associated with overeating and weight gain, cardiovascular, neuroimmune, and metabolic diseases, including in humans. So the signs of biological damage tend to align with clinical hard outcomes. Stress is an age accelerator. In 5 words, that's the summary. Stress is an age accelerator. And as a brief aside, a nuanced note, there were other nuances in this paper. Different senescence markers they used, like P21, SA beta gal, etc. And different responses in different non-social stress models, potential sex-dependent differences, and so on. So if you want to read the paper, I always encourage it. But I'm going to put those aside for now, because I want to discuss the so what and suggest practical solutions that don't involve quitting your job if your boss is a jerk. So combating stressors, tip 1, awareness matters. Awareness is the first step in adaptation. And now that you've watched this video, you have a biological handhold for awareness. I think even or especially when the data are scary, as they are here, I find awareness offers the motivation to seek change. Now, by way of a personal analogy, when I found out I carry not 1, but 2 risk genes for Alzheimer's disease, 2 copies of the ApoE4 allele, at first, I was honestly freaked out. Alzheimer's scares the shit out of me. Sorry. But then I realized this was always in me. But having the knowledge, especially early on in life, it's a gift. It's the motivation and power to take every preventative action. In the end, you can achieve the best outcome in a given scenario. I can't change my genes, but I can change what I do in life and the impact those genes will have on manifesting into reality. And the same goes true for these data on stress and biological aging. So tell me in the comments, do you agree knowledge and awareness is power? Anyway, moving on. Combating stressors tip 2, a growth mindset. Stress is not all bad. Stress forces you to adapt. And the balance of research shows it's not about what the stressor is. It's about how you respond to the stressor. And if you can find a way to adopt a growth mindset in a situation, focus on the positives and focus on your purpose, that's huge. Now, you can skip forward to the next chapter if you don't want to waste time on me rambling about myself, but again, I'm going to share a little bit of a personal example in case that resonates with anybody. So, as a personal example, I've been subject to academic harassment and academic bullying over the course of my still young academic career. I'm not going to share with you the specifics, that's not really important, but to me, this is worse than physical bullying. In a physical altercation, I can punch back if I need to, when I need to. But when someone exerts their academic seniority in a very hierarchical system, especially in medicine, to attack your career, hitting up the hierarchy can sometimes create more pain for you than for the aggressor. Now, the instance I have in mind, it tore me up inside. But ultimately, I did find contentment in a growth mindset. Here, I internalized the truth that the event as it transpired was initiated by an unforced error on my part. I think I did the right thing ethically, but I did it in a way that left me vulnerable to attack. In retrospect, that was dumb, but it taught me not to assume that others will play fair. And that was a valuable lesson about a harsh reality that I'll carry forward with me. The issue is now resolved, thankfully, and I'm wiser for it. So I should be, and I am, grateful for the experience. Also, I focused my energy on my purpose. I'm doing an MD PhD. Actually, I'm a few months away from finishing it after 11 years of higher education, but I'm doing this for you because I love science, teaching, conducting research that can change lives. The practical value of Oxford and Harvard brands, an MD PhD, those letters, it's immense. And I know I will soon be in a position to leverage those credentials for the greater good, this world's metabolic health. Now, to be clear, I am not saying letters and brands should be used as a lever for credibility. I am just acknowledging the realities of our social structure and being transparent that I will play the game that needs to be played in order to make metabolic health mainstream. And the only reason I'm verbalizing this to you now in a video is because I promise myself and you authenticity. So I'd like to take moments aside to present that to you. Anyway, now moving on, tip 3, and moving back to the science, tip 3 for combating stressors is the physiologic sigh, and this might be the most practical of all. So try practicing a physiologic sigh for just 5 minutes per day. This is a structured breathing technique characterized by 2 stacked inhales followed by a long exhale. So a 1-second inhale stacked by a 1/4 second inhale, then a 2-second exhale, like. This physiologic sigh form of breathing is actually a method that Andrew Huberman turned me on to. You may have heard him talk about it. And it's backed by science. In fact, in a randomized controlled trial published in Cell Reports Medicine, researchers, I'll tell you who those were in a moment, compared 3 forms of breathing: a physiologic sigh, box breathing, and cyclic hyperventilation. And they compared this to meditation. And in short, they found that the physiologic sigh performed best overall at increasing positive affect, reducing anxiety, and improving physiological markers like respiratory rate. Furthermore, the benefits of daily physiologic sigh for just 5 minutes per day accumulated as people engaged in the practice for more days. So now, quoting from the paper, we, the research team, found that the cyclic physiologic sigh group had significantly higher increases in positive affect as compared to those in the mindfulness meditation group. Cyclic physiologic sighing also had a significant interaction with cumulative days on protocol compared with mindfulness meditation, suggesting subjects, those engaged in physiologic sighs, benefited more from the exercise the more days they did it, an effect that was not observed in other groups. Now I want to pause for another brief aside, this one on Andrew Huberman himself. One thing I'll note is that Andrew Huberman was the senior author on this paper in Cell Reports Medicine. And I want to note that because you'll notice, if you follow him, Andrew promotes a lot of research, but rarely if ever self-cites. Now this is rare, especially given his position, where he does have the influence to crank up metrics on his own research. He can do that easily, but he chooses not to. And I don't think anyone else has ever before publicly observed this quirk in Huberman's character. So let me be the first, as I think it speaks to his honestly humble character, and that deserves credit, at least in my opinion it does. It's sometimes hard to know the authentic person behind the brand, especially when fame invites vicious attacks. Sometimes they're warranted, sometimes they're outright lies. And how are you, as a member of the general public, to know the difference? So take this observation for what it's worth. Again, I thought it deserves some credit, because I can't think of another single famous researcher who intentionally avoids promoting their own work. It's interesting, at the very least. Do you agree? Anyway, moving on, and in conclusion, I want to end this presentation by speaking to a key question about resilience to consider as this research progresses. Now, it's highly likely there are differences in vulnerability to stress-induced senescence, the topic of this paper. And the flip side of this coin is resilience to stressors, biological resilience to stressors. But what makes one more resilient? Is it about psychology, mindset, or is it primarily metabolic? In fact, in this paper, they note that chronic social stress, the chronic subordination stress, activates known inflammatory pathways, like those stimulated by the NLRP3 inflammasome, which can be inhibited by practices like fasting or ketogenic diets, which generate the molecule beta-hydroxybutyrate, which inhibits the NLRP3 inflammasome. So in theory, certain dietary or lifestyle practices could build resilience to social stress in terms of senescence. My hypothesis is that lifestyle practices, including diet, sleep, and exercise, contribute to biological resilience to social stress. And this highlights their importance in our stress-filled world. Because honestly, stress isn't going away anytime soon. So now I'll ask you, what's your first step? Will you try a physiologic sigh, reevaluate your stress response, or focus on improving your sleep or diet? Take one small step today, and then another tomorrow. Your future self will thank you. And now here are some thoughts from the first author of this paper, Dr. Carrie Lyons, recorded exclusively for you.
Thank you, Nick, for reaching out about our research. The data from our study are exciting because they directly link psychological stress to promoting a fundamental aspect of aging, which is cellular senescence. For a long time, people have had the idea that intense stress accelerates aging, but we didn't really know what biologically was happening to cause this. The study that we recently published found that over time, stress, especially social stress, increases the abundance of senescent cells, and that the first systems where this can be measured are the brain and in circulating blood cells. While our studies were performed in mice, a large body of research has shown that social adversity affects health and lifespan across species, from mice to monkeys to dolphins to humans. In people, multiple types of social stress, including low socioeconomic status, loneliness, and caregiving for a chronically ill loved one, are associated with greater risk of developing aging-associated diseases. So we believe that we can learn a lot about human health in regards to social stress from animal studies like ours. For more on the topic of what seems to be an evolutionarily conserved relationship between social interactions, health, and aging, I'd point folks towards 2 review articles that I'll link for you. The first was published in the journal Science in 2020. First author is Noah Snyder-Mackler. The second I published with my group in 2023 in Neuroscience and Biobehavioral Reviews, and it aggregates the current evidence we have from human, animal, and cell studies showing a link between stress and aging. The other side of the coin of stress research is research into resilience. This research shows that having supportive social relationships predicts better health outcomes in humans and in other species. Additionally, when we talk about stress from a scientific point of view, we're thinking about challenges that the subject experiences as being both uncontrollable and unpredictable. Health studies in humans have shown that people who feel a strong sense of control in their lives, even if they are experiencing social adversity, don't have the same negative health outcomes as people who don't feel that sense of control. I mention this not as a personal admonishment to anyone to take control of their lives, but as something to be conscious of looking at our own feelings and how we make others feel through our interactions and through institutional and public policies, because I do think that social stress should be regarded as a public health concern. Underlying the negative effects of social stress on health, I believe that there are both psychological and metabolic components at play. I'll add that these factors likely interact with each other and could create a bit of a positive feedback loop or have a snowball effect. The next steps for our research can be divided into 2 main lines of inquiry. The first would look at interventions that promote resilience to social stress-induced senescence. One might be providing our stressed mice with positive, non-aggressive social interactions with other mice. In terms of interventions more focused on the metabolic side, my PhD advisor was always very interested in diet and specifically caloric restriction, while I've always been very interested in exercise, given its demonstrated ability to improve both psychological health and metabolic health. Secondly, we would like to look more closely at the specific long-term health consequences of social stress-induced senescence. This could be accomplished by exposing mice modeling a certain disease, maybe atherosclerosis, maybe Alzheimer's disease, to social stress while giving them either a placebo or an agent to kill senescent cells, and then seeing how both the stress and then the removal of senescent cells affects their disease progression.
How does psychological stress impact gut health? And how can we use new science, new knowledge to improve our gut health and our mental health? These are the questions I'm going to try to answer today. So if you or someone you know has ever suffered from bloating, constipation, or GI upset, which I think covers most people, you will want to watch this video all the way through. Now, in this video, I promise you, 1, specifics. I'm not going to wave my hands and use generalist terms, but speak about specific causal cascades linking brain to gut and gut to brain based on new and exciting science. 2, I'm going to offer you actionable takeaways and practices that I myself am going to try to implement because, in truth, this is one video I'm making as much for myself as I am for you. Okay, let's get into the data. The paper in question was just published in Cell, one of the top journals in the world, and is entitled Stress-Sensitive Neural Circuits Change the Gut Microbiome via Duodenal Glands, the duodenum being part of the small intestine. At a high level, the researchers discover a pathway whereby activity in a brain region associated with stress and emotions, the amygdala, controls the vagus nerve, the 10th cranial nerve that connects the brain to the gut and the gut to the brain. And in so doing, the brain can toggle the activity of glands in the intestines called Brunner's glands that make mucin that feeds the microbiome, which can in turn influence GI symptoms and gut health. So again, at a high level, the brain talks via the vagus nerve to Brunner's glands in the intestines that make mucin that feed the microbiome, and this can impact gut health and, in a reciprocal fashion, impact brain and mental health. Now let's look at some of the data together. Now, I do say some of the data because there are 163 figure panels in the main text alone. That's not even including the supplement. I know, right? 163. And if I went through all of these, I think we'd be here for about 18 hours and I'd probably stress you out, which, as you will learn, can have a negative material effect on your gut health. So, let's first introduce the leading gut bug in our story, Lactobacillus. Now, there are actually many different species in the genus Lactobacillus, but for the sake of simplicity, consider Lactobacillus good guy gut bugs. They're common probiotics and also the primary genus found in many considered to be healthy fermented foods like yogurts, sauerkraut, kimchi, and so on. Shown here, the researchers found that by stimulating mucin-secreting Brunner's glands in mice, the Brunner's glands provided nourishment to Lactobacillus to promote their growth. However, surgical removal of these Brunner's glands negated this effect and depleted Lactobacillus levels. So this shows that mucin-secreting Brunner's glands are important for promoting Lactobacillus growth. But the question, what controls Brunner's glands? Well, they found the vagus nerve directly connects the brain to the gut, and specifically connects the brain to Brunner's glands. So if you cut the vagus nerve, the brain can't activate Brunner's glands and Lactobacillus are depleted. So the brain is what's controlling Brunner's glands, along with peripheral hormones. But now, the vagus nerve, what is it? It's involved in parasympathetic, rest and digest, nervous system activity. This is in contrast to the sympathetic, fight or flight branch of the autonomic nervous system. So, high level, we start to form this picture whereby calming, vagal, parasympathetic, rest and digest nervous system activity activates Brunner's glands. And if you want specifics, it's through releasing acetylcholine, a neurotransmitter, onto M3 muscarinic receptors, if you want the details. But this increases mucin production from Brunner's glands to feed and proliferate lactobacillus. And this is consequential because the microbiota in your intestines can directly and through reciprocal activities on the nervous system alter gut function and gut symptoms. In fact, if you knock out Brunner's glands or you cut the vagus nerve connection to Brunner's glands, this can lead to severe gastric bloating, as you can clearly see here. It's quite profound. And it can also lead to leaky gut, increased gut permeability, and heightened immunoreactivity. Now, let's complete the picture by adding the master controller to the system, the brain. The researchers found that one critical brain region, the central amygdala, which is the core of an almond-shaped brain center involved in emotions and stress response, was the master regulator. Indeed, the researchers found that activation of the central amygdala enhanced signaling through the vagus nerve and thus increased Brunner's gland activity to lead to increased lactobacillus and improved gut function. So in this way, the central amygdala in the brain associated with your emotion directly controls the microbiome, which is freaking fascinating. And they show that stress inhibits the central amygdala and that stress lowers lactobacillus levels. Thus, zooming out once again, stress inhibits a brain region, leading to decreased signaling to mucin-secreting glands, Brunner's glands, starving the good guy gut bacteria. And while you can't exactly do these causal mechanistic experiments in humans, these data are very likely relevant to humans, as it's been well documented, shown previously, that stress is associated with reduced lactobacillus in multiple primate and human studies. But going well beyond this correlation in humans, the researchers actually did something quite brilliant in my opinion. They studied surgery patients who had a region of their guts removed, the region containing Brunner's glands. Specifically, they took patients who underwent surgery for non-metastatic gastrointestinal stromal tumors. And what they did was they compared those who had the region of the intestines that contains Brunner's glands to other patients who had similar tumors, but who had surgery with a slightly different part of the intestines removed so that Brunner's glands were actually preserved. So you get this really interesting comparison. It's ingenious. And indeed they found immunological changes consistent with the mechanistic data shown in this paper. Now, this is somewhat an aside, but I think it's a brilliant example of how you can couple rigorous, causal, animal mechanistic models with observational data in humans and natural experiments in humans to demonstrate that the former, the mouse studies, are most probably relevant to the latter, human studies. So, in summary, these data are consistent with a model whereby the central amygdala in the brain signals through the vagus nerve to increase secretions from Brunner's glands, which feed lactobacillus, leading to better gut barrier function, better autonomic tone, less GI upset, less bloating, and overall better GI function. Conversely, stress decreases signaling from the central amygdala to Brunner's glands, thus depleting lactobacillus, starving them off, leading to bloating, leaky gut, among other unfortunate effects. Now, really quickly, before getting into the actionable takeaways that I promised you, astute viewers might have noticed that stress equates to less central amygdala activity, even though the amygdala is often thought about as the fear, fight, and flight region of the brain. So this might seem counterintuitive if you're following, but basically, brain regions are heterogeneous with different neuron populations that carry out many different jobs. So I wouldn't take this as a paradox, just a complexity. And if that went over your head, ignore this last bit, but I did just want to mention that for the uber neuro nerds out there. Now, what can you do to leverage this new knowledge, to intervene on this pathway to improve your gut health? Well, perhaps the most actionable and inexpensive modality is through stress reduction exercises. This includes deep breathing, physiological sighs, yoga, meditation, or just doing whatever relaxes you. Now, on the physiological sigh front, this is a technique brought to my awareness and popularized by Professor Andrew Huberman, and involves a specific pattern of breathing that activates the parasympathetic nervous system. And it consists of a double inhale followed by a long exhale, like and I'll link to more information on that below. And on the user-specific relaxation technique, I want you to seriously contemplate what relaxes you. Often this falls into the category of guilty pleasures. And if you're anything like me, type AAA, you may even avoid these activities by virtue of the fact that they aren't classically productive. However, in sharing the data presented in this video with you, I want you to contemplate that what might not seem productive may actually be productive insofar as it's good for your gut health, and by knock-on effects, your metabolic health. So yes, that means, for me, taking myself as an example, I can rationalize curling up on the couch in a ball and binge watching Game of Thrones or Marvel movies as a metabolically healthy intervention. What do you think of that? Kind of a nice free pass to enjoy yourself, right? But seriously, enjoyment, relaxation, social connection, these are all really important to gut health and metabolic health, and mental health, of course. In addition, consuming fermented foods containing lactobacillus may be beneficial, consistent with this literature, including things like sauerkraut, kimchi, pickles, yogurts, and so on. I personally really enjoy kefir. Metabolic and nutritional psychiatry are exploding fields, now with millions of dollars being poured into trials being conducted at Harvard and Stanford and elsewhere on diet and mental health disorders, including depression. Why? Well, it should be obvious. Your diet impacts your metabolism, and healthy brain metabolism is the foundation for a healthy and happy mind. But it's only just now becoming apparent how powerful diet can be to treat, even cure, disorders like depression. So in this video, I'm going to do a deep dive into the bowels of new mechanistic data. But I promise to tie this back in to human clinical trials at the end. Trust me, you're gonna wanna watch this from beginning to end to fully appreciate the metabolically elegant dance among our diets and brains, and because there are some interesting surprises at some point throughout the video. So the paper that has me so excited was just published in Neuron, and it reviews how bile acids, molecules that are made by our bodies and released into our intestines to help break down fat, well, these bile acids can be endogenous antidepressants. Mind blown, right? Well, not yet. The first thing to understand is that bile acids aren't just released into our intestines, but are also released into the blood and circulate throughout the body. This makes sense at a high level, since these molecules are serving a function in responding to what we eat to help us break it down, specifically break down fat. They shape our microbiomes, and so if our bodies were smart, and they are, they would also couple bile acids to the regulation of whole body metabolism, including brain metabolism, which is exactly what our bodies do. Now, one key receptor for bile acids is called the Takeda G protein coupled receptor, or TGR5 for short. And as an aside, if you're like me and wondering why it's called Takeda, I did look this up, and the etymology of Takeda translates to warrior rice paddy in Japanese. That's all I got. Someone can tell me a little bit more in the comments. Anyway, getting back to business. Bile acids bind TGR5 all over the body to alter metabolism, including binding TGR5 in the brain. And researchers in this study found that stressors, including subjecting mice to chronic social defeat stress, which is dominance by an aggressor mice, and resistance strain, which is restraining mice in these little tubes, sorry mice, basically stressing mice, decreased levels of TGR5 in a brain region called the hypothalamus, specifically the lateral hypothalamus. And this was specific to mice who were susceptible to stress-induced depression, as you can see here. So the hypothalamus is the master regulator of the body's hormonal system and the body's stress response axis, the hypothalamic pituitary adrenal axis, or HPA axis. And they also found that in stress-induced depression mice, there was an association whereby lower levels of TGR5 in the hypothalamus associated with less social interaction, which is a sign of anhedonia, or a depression sign that's the inability to feel pleasure. So we're starting to develop this picture here. in this study? Could it be that stressors lower TGR5 levels in the brain, and lower TGR5 signaling promotes depression? Let's now develop that picture a little bit more. Indeed, the researchers found that in depression-susceptible mice, stress increased levels of stress hormones like cortisol. You've heard of cortisol, right? And cortisol can bind to its receptor in the brain, the glucocorticoid receptor, and this can then go and bind DNA elements to downregulate expression of the TGR5 gene coding for the TGR5 protein, the receptor, in the hypothalamus. So basically, stress promotes cortisol, cortisol decreases TGR5, and that promotes depression. But wait, something's missing. How? How do decreased TGR5 levels contribute to depression if indeed they do so? Well, what the researchers find is that TGR5 signaling inhibits off or inhibitory GABAergic neurons in the hypothalamus. So more TGR5 signaling basically shuts down these neurons, the neurons that researchers actually ended up finding promote depression. Conversely, less TGR5 signaling, as in the stress-induced mice, removes the shackles on the depression neurons, leading them to induce a depression-like phenotype. Now, stepping back, how they demonstrate causality in this pathway at a high level is basically by blocking and activating various nodes in the pathway, which they do quite elegantly using techniques I've covered previously in other videos like optogenetics, which is pretty cool. You should go check out this video, this timestamp, for more on that. But the data, the primary data, they look like this. As you can see, they're pretty complicated, so I've made the executive decision not to figure bomb you, nor get into the nitty-gritty about dendritic spine morphologies, even if there were a bunch of jokes I really wanted to drop on mushrooms. Anyway, I'm gonna kind of move over the nitty-gritty, in part to help with YouTube video retention. Yes, I did admit that, but also because I want to encourage you to read the paper yourself, and I wanted to get on to how these mechanistic data relate to human data, how they're more relevant to you. As I mentioned, there have recently been a slew of studies showing that carbohydrate restriction and ketogenic diets can improve mental health disorders, including bipolar disorder, schizophrenia, and depression. Now, we know that ketogenic diets can treat depression and save lives. But how? How ketogenic diets and carbohydrate-restricted diets work remains a metabolic mystery. The exact mechanisms are likely multitudinous, but this mechanism highlighted in this paper may be one, whereby high-fat, low-carb ketogenic diets increase levels of TGR5 signaling bile acids in humans. This has been shown. Better understanding of these mechanisms has several functions. First, I think it enables innovation of more targeted treatments. Some questions that arise in my mind: could it be that bile acid response to ketogenic diet actually predicts improvements in depression? Or could it be that different ketogenic diet compositions could lead to more favorable bile acid profile and lead to more impactful clinical results on depression? These are possibilities. Additionally, providing biological plausibility in preclinical models, including mouse models, motivates investment in more research that needs to be done. And on this, I really want to add, doing rigorous human trials is difficult. This is in large part because of financial constraints and the lack of a clear business model for metabolic mental health. Pharma has no reason to want to fund these studies, but they need to be done. So they're getting done in large part because of funding from philanthropists. One example is the Bazooki Group, who are motivated to fund this work because their lives and or those of loved ones have been touched by mental health disorders. They've suffered terribly, only then to feel the full power that dietary and metabolic health interventions can have in treating severe treatment-resistant mental health disorders, like treatment-resistant depression. With that, I'm going to pivot a little bit and provide some closing thoughts that are going to be sentimental, starting with a quote from the late, great Robin Williams. He once said, "People don't fake depression, they fake being okay." Now, Robin Williams' suicide, when it happened in 2014, was the moment that I realized that anybody can struggle with mental health issues, and it's often not visible. He was a figure that, in my childhood, was always a symbol of joy, humor, and vitality. The kind of person who could touch your heart without ever having met you. So this video, as awkward a tribute as it might be, is a tribute to Robin Williams. Now for that special surprise I promised you. Here's a little bit from Zach Williams, Robin Williams' son. I posed to him the question, what does metabolic mental health for you, and why do you think it's important to study this? What do you think the future of metabolic mental health is? Respond however you please. So Zach, take it away.
Hi, I'm Zach Williams, the mental health advocate. And mental health has always been a significant part of my life, and today I want to talk about something that isn't often discussed but is incredibly important: metabolic mental health. For me, mental health isn't just about what's going on in your mind, it's also deeply connected to what's happening in your body. I've experienced firsthand how closely linked our physical and mental well-being really are. After years of struggling with anxiety and depression, I discovered that addressing my metabolic health, things like my diet, exercise, and sleep, had a profound impact on my mental state. So, what exactly is metabolic mental health? It's about understanding that our brain and our body aren't separate systems. They're deeply intertwined. Our metabolism, the process by which our body converts food into energy, plays a crucial role in how we feel mentally. When our metabolism is out of balance, it can lead to feelings of fatigue, stress, and even mental health issues like anxiety and depression. There's growing evidence that our diet, our gut health, and our overall metabolic function can influence our brain chemistry. For me, taking care of my metabolic health means being mindful of what I eat, staying active, and making sure I get enough rest. It's not just about avoiding junk food or hitting the gym, it's about understanding how my lifestyle choices impact my overall well-being. I've learned that when I support my body's metabolic processes, I feel more energized, more focused, and more resilient mentally. I encourage everyone to explore this connection between metabolic and mental health. It's about finding a balance that works for you, whether that's adjusting your diet, incorporating more movement into your day, or simply paying attention to how your body responds to different habits. By nurturing both your physical and mental health, you can create a foundation for long-term well-being. Remember, mental health is holistic. It's not just in your head, it's in every part of your body. By taking care of your metabolic health, you're also taking care of your mental health. And that's something worth investing in.
I know you know who this man is. It's Joe Rogan. And if you listen to Joe enough, you'll inevitably hear him say that doing hard shit, sorry, paraphrasing, but especially strenuous physical exercise is good for you. And according to Joe, strenuous physical exercise is not only good for the body, but good for the mind and mental health. And Joe Rogan is here dead right. In fact, Joe doesn't even know how right he is. But after watching this video, you'll be able to teach him and all of your gym buddies something really cool about physical exercise and mental health. So let's get into the data. These brand new data from Cell Metabolism reveal the molecular mechanism by which intense physical exercise is good for mental health, and specifically how intense physical exercise alleviates and protects against anxiety. And the star metabolic player in this story is lactate, a byproduct produced during intense physical exercise. But here is something you probably did not know about lactate. In addition to being a molecular byproduct and fuel source in its own right, lactate can be used as an intracellular signaling molecule to change the functions of proteins and enzymes within cells. And lactate can be physically attached to proteins in a process called lactylation. And when this lactylation occurs in the brain, it can change brain function and mental state. So, the authors of this research paper hypothesized, now quoting, "We propose that exercise might modify the protein lactylation pattern within the brain, conferring resilience against stress." So, here's what they did to test their hypothesis. They subjected mice to chronic resistant stress, which is where you trap mice in a little small space, which promotes anxiety behavior in the mice, as can be assessed with validated behavioral tools, like open field or elevated plus maze testing. Specifics aren't really important for this discussion. However, when the mice were additionally provided with 1 hour per day to run on a treadmill, this increased lactate levels in the brain, and the anxiety effect was negated. And what's more, when the mice were injected with lactate instead of, not in addition to, but instead of exercise, anxiety was still blocked. And furthermore, when the researchers blocked lactate production during exercise, the anti-anxiety effects of exercise themselves were reduced. So this is all consistent with a hypothesis that lactate is mediating the anti-anxiety effects of exercise. But the next big question is what protein is being targeted, is being modified by lactate to mediate the anti-anxiety effects of exercise? And the researchers discovered it was a protein called SNAP91. Lactate tagging, or lactylation of SNAP91, was decreased by chronic psychological stress and increased by exercise, which reveals a molecular push and pull whereby exercise offsets the metabolic signature of chronic psychological life stress. So take a look at this here, because this is beautiful. This shows the healthy state of SNAP91 in the medial prefrontal cortex of the brain, in the top row, where yellow is lactate-tagged or lactylated SNAP91. In the middle row shows what happens under chronic psychological stress. You can see a massive downshift in SNAP91 lactate tagging. But what happens when you add exercise to the mix, when you add exercise to chronic psychological stress? As you can see, the effects of chronic psychological stress are reversed. The yellow comes back. It's amazing. Now, if you're smart and curious, and I know you are, you're probably wondering about what SNAP91 does. SNAP91 is important in assembling vesicles and helping to maintain the healthy release of neurotransmitters and overall healthy synaptic function. So basically, SNAP91 is important in maintaining healthy signaling among neuronal networks. And the modification of SNAP91 has functional implications too, as chronic stress leads to decreased lactylation of SNAP91 and decreased markers of neuronal transmission and function, which is reversed by exercise. Finally, to really hammer home the point that intense physical exercise increases lactate in the brain to increase SNAP91 lactate tagging and change neuron function to reduce anxiety, the researchers tweaked the SNAP91 protein in mice specifically at the amino acid where lactate likes to attach, just there and nowhere else. And even this tiny molecular tweak abolished the anti-anxiety effects of exercise and the associated metabolic and functional changes induced by exercise. And all this helps to cement the causal cascade whereby intense physical exercise increases lactate in the brain to increase SNAP91 lactate tagging and change neuronal function to reduce anxiety. Isn't that cool? Now, returning to the unexpected wisdom of Joe Rogan, who values hard physical labor for both physical and mental health, I want to reinforce the practical key takeaway from this paper. Lactate, it's a marker to reflect the intensity of exercise. More hard, intense work means more lactate. And lactate is the molecular mediator of the anti-anxiety effects of exercise. Thus, there's actually serious science behind the idea that high-intensity work, that work that leaves you feeling like you're about to die, can have anti-anxiety, pro-mental health effects, not just through habituation and psychology, but through hardcore metabolic science. So the next time you're working your butt off doing hill sprints or muscle ups or burpees or jumping alternating lunges or whatever makes you feel like you're about to die, think about the fact that the lactate that's building up in your body and your brain is affecting molecular changes that will make you more resilient to stress. That's pretty badass.